Hello, welcome to Tiny DevOps. Quick, before we get started, tell me your opinion. Do you prefer A
Ladies and gentlemen, the Tiny DevOps Guy.
or B?
Ladies and gentlemen, the Tiny DevOps Guy.
Today we're talking about A/B testing. Hello and welcome to another episode of Tiny DevOps, where we believe you don't need 1,000 engineers to do amazing DevOps. I'm your host, Jonathan Hall, and today we're going to talk about A/B testing on small teams. My guest today used to run A/B testing at Booking.com, and he's now working with Vista. Lukas, welcome to the show. Would you introduce yourself briefly?
I don't know how much introduction you want, but I'm Lukas. I was responsible for A/B testing or experimentation in general at Booking for 8 years, and now I've joined a company called Vista, which is also an online presence, but they have physical factories where they print stuff like T-shirts and caps and business cards and paper, and it's a whole new world for me because it suddenly opens up this how do you do experimentation on the factory floor, which is fascinating.
This may be a little bit of an unusual topic, considering that you do, or your expertise, or at least the part of expertise I want to talk to you about, is A/B testing for big companies. But I think there's an overlap here, and that is that
Absolutely.
for the last two companies I've worked with, where we had, so the very last one was a startup with 0 clients at the beginning, 0 customers, but they were already asking to do A/B testing, and they tasked my team with give us the data and give us the infrastructure to manage the data to run our A/B tests. And of course, my thought is, you have 0 customers. What are you going to be testing? And then we had a similar situation at a company before that where they did have clients that they were selling e-commerce stuff, but we had a few thousand visitors per day. So I was hoping you could provide some insight to anybody who's might be in a similar situation. They're on a small team without a lot, or maybe not. It's not the size of the team so much that matters here. It's how big the customer base is or how much traffic they're getting. Is A/B testing valuable in this situation?
Oh, this is one of my favorite topics. Okay. The first thing I'd like to point out is that people talk about Booking.com as an example of a company who is very large and can therefore do experiments. But the reality is that Booking.com started experimentation in 2005 when they had a total of 5 developers
Okay.
in the entire company. So the whole idea that Booking can afford to experiment because they're big is just a fallacy. That is, the counterexample is Booking.com itself, where they started running experiments when they were really, really, really small. And I think there is an argument to be made for that. One of the reasons that Booking got so big is the fact that it started experimenting small. And so I think we should stop using Booking and some of those other companies as examples of experimentation only works when you're big. I think the other thing I'd like to say is that when you're as big as Booking.com, you get a lot of traffic. And in fact, from a business point of view, you actually do need that much traffic in order to pick up effects that are interesting. And the reason I point that out is that when you think about a business context, we are usually interested in the absolute magnitude of effect. How many additional dollars are we making per day, or how many customers are we helping? And the weird thing is that the way that you would pick this up in an experiment is through a concept called statistical power. And statistical power grows quadratic or logarithmically. There's a square root in there somewhere, which means that if you want to pick up an effect that is half the size, you need to quadruple your traffic. Now, from a business point of view, if you quadruple your traffic, then the impact of half the size effect is still double what you could have measure if you had less traffic, right? So from a giant business point of view, this is actually working against them. The more traffic you have, the more money there is on the line, and the more difficult it becomes to actually pick up something that is meaningful. And so I actually think if you reason this through, that smaller companies actually have the advantage.
Okay.
Because yes, a smaller company cannot pick up a 0.1% difference in the conversion rate or revenue or whatever they're interested in, but they also, from a business point of view, should not be interested in a 0.1% difference, because that's not going to make or break their business. A startup should be growing double digits, right? They should be looking at those things that are impacting the business by 10 or 20%. And those impacts are very, very easy to measure using a controlled experiment. And so I would say, like, from that point of view, not only is it a fallacy to point to Booking.com and say, oh yeah, they're big, they can run experiments, because it's a fallacy because Booking started when they're smaller. It's actually easier when you're smaller. And so I would say especially small companies should be running experiments. Now, where is the overlap with DevOps? I'll get that so after this little rant. I'll go into DevOps. Is that the way that most of these companies make experimentation at scale work is they decouple code release from feature release. Mm-hmm. And in a traditional IT setting, the moment you deploy the code is also the moment that the feature goes live. And this is problematic for many reasons, especially when you scale out. And I think one of the genius things about the DevOps movement is that you're making individual product development teams own the feature when it goes into production. And the way that you usually do that is you decouple code release from feature deployment through some sort of toggling mechanism, right? And that could either be something that you built in-house or some SaaS solution that you use, or something that allows you to put code in production without making the features go live. And then at any convenient point, a point that is convenient to the dev team, you say, actually, now I want the feature to be shown to customers. And that's when you toggle it on. Now, that sort of toggling mechanism is also the foundation of A/B testing. Because when we're putting these A/B testing platforms into production, we need the ability to control treatment assignment. That is, we need the ability to decide in the moment for an individual user, are we going to show them the new version or the old version, the A or the B? Mm-hmm. And to be able to do that, the code actually needs to be able to do exactly what you need for the DevOps movement, which is it needs to be able to run both the old and the new version of any change and any combination of changes that have been entered into the code. And so from that point of view, there's a very, very close technical tie, I think, between the DevOps movement and the experimentation infrastructure. And the other one, I think, is that the DevOps movement, at least my reading, I'm an outsider, right? So my reading of it, after reading, the Phoenix Project and Lean Startup and all these books, is that it puts a lot of emphasis on providing development teams with direct feedback on how their features are performing in production. Not throwing it over the wall and saying, oh, the operations team will figure out how to make this scale. Or it does exactly what it says in the specification, so my work is done. Right? But actually getting these development teams to care about and to monitor and to check when we put this in production, does it actually do what we want it to do? And that is one of the things where experimentation also is very much interested, because the whole point of doing experimentation in a business setting is that when we're making these changes to products, we often don't know how they will behave in production because, and this is a little pun, so please excuse me, but we often talk about unit testing and then integration testing, systems testing, right? And the idea behind the integration test is you get all the systems that are involved in the entire operation of the product, and you test everything at once. Well, most consumer-facing and even B2B-facing products have a user that is supposed to be doing something with the software. And I would argue that unless you have run a test that included that user in its natural habitat, you have not actually done an integration test. You've done a very extensive unit test where you tested the software component of your application, but you have not yet tested end-to-end what actually happens when I put a human brain that I do not control, so not a QA engineer that's following a script, but an actual customer or an actual business user, put it behind the software, let them use it without additional instruction, and then see whether they actually interpret the software the same way that we thought they were going to. And you'll find that in many cases, they don't.
Right.
Because it's very difficult to predict how users will behave.
Mm-hmm. That's a great rant or introduction.
Oh,
I love
yes.
that. I love that.
The thing is, I've done, I like this spiel. This is a spiel, right?
Yeah,
I've
of
done
course.
this 1,000
I
times.
can tell.
I do consulting for clients. I do conferences, right? I run my own side business as an independent contractor, and all of them need to hear this again and again. That's why I'm here also, because I think there's too much, um, dare I say, Dijkstraism in software development, where Dijkstra famously said he doesn't understand why software needs versions, because you write the spec, then you write the proof, then you write the code, and then it's done. And we find that laughable now, right? We say, well, obviously that's not how you actually develop software. And I ask you why? Why do we not develop software that way? Because if it was true that the world was predictable and we could predict how the software was going to be used, then that's exactly what we would do. It's very efficient, right? You write the proof for your software, you put it in production, done. But the reality is that we're interacting with these human systems, the human customers or human users, that we do not fully understand. And so it's a fallacy to think that we can write the full proof if we don't understand the black box that is the human brain.
Yeah. So it's a fallacy that we need millions of visitors per day to start doing A/B testing. Is there a floor? Is there a minimum that we need?
Oh, well, kinda. This is tricky. This is a trick question, Jonathan. You're setting me up for something.
I know.
So let's go back a little bit. The methods that we're using for A/B testing, at least when we're looking at frequentist statistics, were designed largely in part by a man named, well, we don't really know his name. I think we know his name now, but he went under a pseudonym called Student, and he was the man who invented Student's t-test. And he invented that Student's t-test while he was running experiments on yeast, because he was working for Guinness. And Guinness didn't want him to publish under the name Guinness, so that's why he was using a pseudonym. But he was running experiments where the number of participants or petri dishes was in the orders of 20. And if you look in the psychology community right now, where the 20 is still the norm for a lot of experiments, there's discussions on whether that should be raised to 50 participants. But you have to keep in mind that in those experiments, we're looking at very immediate things that we can measure and very large effects. And that the smaller the effect or the longer the delay between treatment and effect, the more participants we will need to effectively measure something. And like I said earlier, if you are a business like Booking.com or Vista, and you want to measure, I don't know, impact on lifetime value of a customer, this is such a long and delayed metric, and you want to measure 1% or 0.5% of difference. This is such a small effect that those things combined means that you really need a lot of traffic. But if you're a much smaller business and you say, look, we are changing rapidly. We are making lots of changes. We want to make sure that our website isn't drastically breaking business performance. And by drastically, we mean we don't want to lose more than 5% of our business. And by business performance, we mean we don't want to lose money the same day, right? I'm now severely constricting both the length that it takes me to measure, so the distance between treatment and effect, and the size of effects that I'm interested to detect. And in those cases, you can get away with hundreds, maybe thousands of participants for each trial. And that should, for a lot of startups, should already be attainable, right? Unless you're some sort of B2B startup where you have 5 customers, which happens, in which case I would just call them up, I guess, if there's only 5 of them. But if you're in the hundreds or even in the thousands as a startup, you can already start experimenting. But you have to keep in mind that you have set on this path saying that 5% is the meaningful difference that you're interested in, or maybe even 10. And so anything smaller than that, I cannot hope to pick up. And that's fine, right? Because from a business point of view, that's not so interesting. But it means I can't start, changing the color of a button and hoping to find a 0.5% increase in conversion. Much rather, you would be looking at, hey, we're thinking about replacing this backend system by a new search engine, right? And we're worried that it might actually delay performance or that it would degrade the customer experience. And in those cases, you have reasons outside of the experiment to want to make this change. So you're not looking for a lift per se, but you might decide not to proceed if it actually does cost you 5% of your business. So within Booking.com, we changed our tooling so that we were able to run a type of test that's called a Non-Inferiority Trial, which is also used in medical trials. When I want to replace an existing type of medication with a generic, saying this generic should do exactly the same thing, it's just 100 times cheaper. Then they run a trial where the intent is not at all to improve the efficacy of the drug, but the intent of the trial is to show that it's not meaningfully reducing patients' response to the drug. And so you almost run an opposite experiment, right? Where the point of the experiment is to show that there is not a 1% drop or a 5% drop or whatever you're interested in.
Fascinating. If we're trying to measure something, and you already started to answer this, but suppose you only have 5 customers, or you haven't launched yet, and you hope to have 1,000 in 6 months, but you want to start making data-driven decisions. Are there alternatives to consider other than just calling all your customers?
Yeah, it's funny. I was talking about this morning because I think we have to distinguish between the statistical and technical apparatus that is A/B testing. So statistics being an A/B test is another word for a randomized controlled trial, where we flip a coin to decide who gets what, then we treat them in some way, then we compare those two groups, A and B, using a type of statistical test, and then we check whether we see a difference that is unexpected. Right? That's sort of the statistical mechanism that's behind the randomized controlled trial. The technical aspect being we need the code to be able to do both A and B, and we need to be able to identify customers and then assign them and measure. Right? So those are the statistical and the technical apparatus. But at the meta level on top of this, there is the scientific method, which is the idea that I have an idea, I come up with a way that I can test this idea, I write that down so that I can show that this was my idea, that this is what I was going to do. This is the method section. Then I run the test, I check the results, and I check them against what I had written up front. No cheating, yeah? I'm going to test it against the previous thing. And then I document and share my results, show it to other people. This is the scientific method, and it is agnostic to what type of test is under the hood. So one of my favorite examples is Edmund Halley from Halley's Comet. He started thinking about why is it that comets seem to appear at a regular interval? Because he was looking at the table data of when these comets appear, and he kept seeing these repeating patterns. And he said, what if they are actually on a loop like the Earth is moving around the sun, but the loop is just much, much larger? And he found this one comet that seemed to be coming back every 120 years. And he said, well, if my theory is correct, that this is on a loop, then this comet should reappear on that particular day in that particular position. So he made a very precise prediction of when the comet would appear. Then sadly he passed away because 120 years is a long, long time. But other astronomers were still watching the skies by the time his prediction came around. And it turned out that he predicted I believe in August of a particular year the comet would appear. And nothing happened in August, September, October, November, beginning of December. And so astronomers said, well, you know what? This Edmund Halley guy, he's full of crap because, he predicted that this comet was to appear and it didn't appear. Until on the 23rd of December of that year, the comet finally did appear. And in hindsight, we know this is because the comet passed one of the outer planets, and the gravity of one of the outer planets slowed down the trajectory of the comet so much that it arrived 4 or 5 months later. But it did appear, and that's when astronomers said, well, actually, you know what? This Halley guy, he might be onto something, because his prediction for the comet was so precise, as in it was precisely this year, and also the way that the comet looks is exactly what Halley had described, and therefore there might be merit to his theory. And I like that example because it shows that the scientific method of I have a hypothesis, I make a prediction, then I test that prediction and I validate it against what I predicted, that this works even if you are dealing with n equals 1, right? One comet in an uncontrolled setting, and my data set is limited to one timestamp, because that was all that Edmund Halley predicted. And the reason it works in this case is because his prediction was very precise, right? He predicted a particular year and month and location, but also because it's very unlikely that comets appear. If Edmund Halley had said, well, you know what, somewhere in the next 200 years, I don't know which the year precisely, a comet's going to appear somewhere in the northern hemisphere, that would not be precise enough for us to use that as evidence for the theory. If, on the other hand, comets were a daily occurrence and they would show up every day, then it also wouldn't work because, we don't distinguish this special day that the comet does appear. And so the combination of something that is very unlikely to occur and then very precisely predicted is what makes the method works. And it's agnostic to how you actually validate that prediction. Now, in the A/B testing case, the nice thing about A/B testing is that we can pick up much smaller effects with much fewer assumptions. And so we don't have to be as precise or as unlikely as a comet in order to use this method to make predictions and test them. But in principle, these things still work. If you're a small startup and you say, I don't know, I think we should add insurance to our product. I think our customers will love that. We have only 5, but you know what? We can run an experiment. We're going to call all 5 of them. And we're going to ask them a very specific question. Would you be interested in purchasing insurance from us at this particular price point? And if more than 2 of them say yes, then we'll take that as an indication that there is interest. And if this doesn't happen, then probably there's no interest, right? That's an experiment. Mm-hmm. You have just designed it's a pretty rough experiment, but the mechanism still works.
We're getting close to the end of our time. What resources can you recommend for anybody who's interested in learning more about A/B testing or the scientific method as it applies to business development?
Oh boy. Okay. So to start with the last one, there is this book, Experimentation Works, Stefan Tomke, Harvard Business School. Disclaimer, there's an entire chapter about Booking.com and my name is in it. But I think it's a good business summary of how experimentation can drive a company forward and which companies are applying it how. So if you're interested in how can a business use experimentation to improve their own product, then this would be my go-to book. If you're interested in the technical aspects of running experiments in an online setting, so online A/B tests, then this book, Trustworthy Online Controlled Experiments by Ron Kohavi, Diane Tang, and Yaju, is a very, very practical, technical guide on how you would implement A/B testing. Assuming that you've decided that this is what you want to do, right? Then how would you actually build the machinery to do this at scale is a good book. If you're more interested in the philosophical, statistical aspects of experimentation, so throw away all the business side and throw away all the technical side. Just like why is randomization important? Like what does this actually do for my results? How do I control for things? What is different types of clustering, for example? Then this classic Field Experiments by Gerber and Green is classic. They're science. I think they're political science actually. Yeah, the political scientists. So a lot of the examples in this book are about, I don't know, people going door to door and trying to convince you to vote Democrat or Republican, right? Okay. So that's the sort of experiments that they're interested in, but the theory is still very much the same. So those are my favorite books. And then last one, if you're interested in sort of at a meta level, the philosophical foundations of how the scientific method actually works, then this is a classic. It's a bit heavier than the rest, but it's The Structure of Scientific Revolutions by Thomas Kuhn. It's a bit dated. It is not an easy read, but it's a classic in terms of getting a sense of science isn't objective, man. It's just someone's opinion, well documented and vetted by other people, right? And so I think Kuhn was a big force in that.
Great resources. I'll put those all in the show notes so anyone who's interested can follow up. And before we sign off, is there, if people are interested in getting in contact with you, if they want to hire you, you said you do some consulting, how can we get in touch?
My name.nl, NL for Netherlands. So on my website, there should be a contact form in there. Otherwise, just my first name at my first and last name.nl. So.
Great. Is there anything you'd like to add before we go?
No, actually, I want to ask you a question. And and maybe this is one for your audience as well. I'd love to get feedback on this. But one of the things I'm struggling with is, can you do experimentation at scale without DevOps? And can you do DevOps without experimentation at scale?
That's a great question.
Because I don't know. I'd love to see it.
Yeah. So the way I define DevOps is that you don't have to throw anything over the wall of confusion. That the developers and operations and ideally other departments, QA and whoever's contributing to the product, they're working together, and there's never this idea that I'm done with my part, you go to your part now.
Yeah.
Can you do experimentation with the wall of confusion? In theory, I suppose you probably could. So in that sense, you probably can do experimentation, A/B tests. Just imagine if NASA wanted to do an A/B test, then it would probably be an A/B test without DevOps.
Right.
So it's probably possible. It would probably be very difficult and painful, and I wouldn't want to do it. But it's probably possible, at least on paper. If you have enough bureaucrats pushing paper around and shoving things through, you could get it done.
Yeah.
So
it'd be difficult to get those teams to care, though.
Definitely. Yeah. So, and then the other question was, can you do DevOps without experimentation? I think the theoretical answer is probably yes, but why would you want to? I mean, supposing you converted your organization to DevOps and just stopped and said we're never going to change anything else again.
Right.
Are you still doing DevOps 10 years later? Maybe, but there's no joy in it. The whole reason that DevOps is fun is because it allows you to react to change quickly, and that's all about experimentation.
I think the moment you go into DevOps, developers will care. They will want to know, like, why does this not work? Or what happened here, right? The moment you give them visibility on how their work is actually performing in production, you almost automatically get experimentation.
I mean, the whole DevOps philosophy, if you've seen the little figure 8, the infinity sign,
yeah,
it's all about feedback loops and shortening feedback loops. Oh, you have it there, yeah.
Yeah, it's on my wall. Yeah.
So, I mean, if you take experimentation out, and of course, I'm not talking A/B testing here. I'm talking any form of experimentation. Hey, what if we did this other thing this way? What if we split into groups of 3 instead of 6, or anything like that?
Yeah.
If you're not doing that, you're maybe by some definition you're doing DevOps, but God, go find another job. That's a terrible place to work.
Ultimately, it's about feedback, right? It's about trying things and then getting feedback on your work in a real setting. I love the NASA example, by the way, because I'm grinning because that is used so often when people want to ask me a loaded question. They ask me, but NASA doesn't run A/B tests. I'm like, do you have any idea how much NASA is experimenting? Right? They build these tiny little rockets. They shoot them up in the air. They measure everything. They try to figure out like what balance works best. So they're experimenting the crap out of this thing because they need to make sure that once the proper thing goes up in the air, it actually does go up in the air. Right. So they're experimenting a lot.
They are.
And no, they're not running controlled experiments, but they probably can't.
But that you see the picture behind me. That's a SpaceX launch.
Right.
And that's because that's my kind of go-to analogy for. Can we do Agile? And people say, well, we can't because we're doing rocket science or something big. We're like, SpaceX does Agile all the time. They send up 6 rockets a week or whatever, and they see what went wrong and they change it. So,
thank you, Jonathan. This was a blast.
Great. Thank you. Thanks a lot.
Cheers.
Have a great day. Bye.
Bye.
Find Lukas Vermeer online at lukasvermeer.nl. LUKASVERMEER.nl.